everyone, welcome to Mathworld. This video is to discuss Cambridge International A-Level Mathematics Paper 3, which is the Pure Mathematics 3 for October-November 2019, and the code is 9709/32. So, if you would like to support this channel, please like the video and subscribe to the channel, and also share it with your friends. Okay. Other than that, you also can click the thanks button below the video to support the channel. Alright, thank you. Let's start the paper. Okay, so for question number 1, solve the equation 5 ln 4 minus 3 to the power of x equals to 6. Show all necessary working and give your answer correct to 3 decimal places. So first of all, I will rewrite the question. Now, when we solve means that we need to find the x. So first of all, the 5 will be moved to the other side, becomes divide. Okay, so here I will be getting ln of 4 minus 3 to the power of x equals to 6 over 5. Then from here, to get the x, we need to eliminate the ln. So for your information, to eliminate the ln, we need to take e both sides, because e ln a, it will be a. So that means here is going to be e ln 4 minus 3 to the power of x equals to e to the power 6 over 5. Then for the left hand side, it will be 4 minus 3 to the power of x equals to e to the power 6 over 5. Then at last, to get the x here, right, I need to make the 3 power x as positive value. So I will move it to the other side and move the exponential to the left side. Therefore, from here, I will be getting 3 power x is 4 minus exponential 6 over 5. Okay, and again, your x is the power right now. So to eliminate the base, which is a 3, we have to take ln both sides. Because ln, right, we have a formula ln a power of b, it will be b ln a. So which means I will just take ln both sides. So ln 3 to the power of x equals to ln e minus 4 minus e to the power of 6 over 5. Therefore, the left hand side, you can just apply this formula and bring down the x. So it will be x ln 3 equals to ln of 4 minus e to the power of 6 over 5. And from here, to get the x, this ln 3 will be moved down. It's like dividing the whole equation by ln 3. Okay, and according to the question, you need to leave your answer correct to 3 decimal places. So from here, just take out a calculator and calculate all the numbers. At last, you will be getting negative 0.351. So that is the solution for question number 1. Okay, now next question, number 2. The curve with equation y equals to exponential negative 2x over 1 minus x squared has a stationary point. So whenever you see stationary points, means that dy over dx equals to 0 in the interval of x between -1 and 1. Now firstly, find dy dx, and hence means use the dy dx or use the previous answer to find the x coordinates of this stationary point, giving your answer correct to 3 decimal places. Okay, so y equals to e negative 2x divided by 1 minus x squared. Now, this is division of 2 functions. Therefore, we need to apply quotient rule. Okay, quotient rule says d over dx, u over v, this is over v squared, and the numerator will be vu prime minus u v prime. Okay, so now from here, I will write down my u and v first. So which means my u is basically e negative 2x. Then now my u prime, when you differentiate exponential function, so differentiate e mx or efx, I will write efx. So from here, you will just rewrite the whole exponential function, and now you differentiate the fx, it will be f prime x. Okay, so from here, I will be rewriting the e negative 2x, and now when you differentiate negative 2x, it will be negative 2. Okay, so now followed by v equals to 1 minus x squared. this is the quadratic function. So your v prime differentiate 1 because it's it's a constant, there's no x, therefore you'll be getting 0. And keep the minus, differentiate x squared, it will be 2x. Now, apply this quotient formula to get the dy dx. So your dy dx is basically v squared. So now you square the quadratic function and then rewrite the v, rewrites the denominator. Okay, and then u prime. U prime is negative 2e negative 2x. Followed by minus uv prime. U is exponential, negative 2x. The v prime is negative 2x. So from here, because the question says find dy dx, that means you need to simplify. So when I simplify, I will not expand the denominator. Denominator just rewrite. But then the numerator, you may factorize a common term. So from here, I notice that the exponential is in common, and then minus 2 also in common. Okay, so I will factorize minus 2 exponential negative 2x. So from the first bracket or first term over here, once you factorize the second bracket, I still have 1 minus x squared, 1 minus x squared. And then for the second term, once you factorize that 2 ticks, right, I still have negative. I still have negative here and the x over here. So it means that I will only get negative x. Okay, and I notice that I cannot factorize or I cannot simplify this quadratic function inside the square brackets. That means this is my dy dx. So done for the first part, dy dx, and hence find the x coordinate of the stationary point. So now stationary point means dy dx equals to 0. Then from here, I will write 0 equals to negative 2e negative 2x multiply with 1 minus x squared minus x over the quadratic, square of the quadratic. Now, when you're solving this, okay, so it means that you move up the denominator, but it is still 0, which means my next step is going to be 0 equals to negative 2e negative 2x multiplied with 1 minus x squared minus x. So when you have multiplication of two terms equals to 0, means one of them must be 0. But then when you write exponential negative 2x, just for information, if exponential x, this is a graph, okay, touching 1. If exponential negative 2x, that means it is 1 over ex. So e negative x is basically 1 over ex, which means you will be getting this result. Okay, so then from here, when you times a negative 2, that means it will be below the x-axis. And here becomes negative 2. So it will never touch the x-axis, right? That means it will never be 0. So from here, this is my y equals to negative 2e negative 2x. This is y equals to e negative x. Now, from here, I know that negative 2e negative 2x cannot be 0 based on the last graph. Okay, therefore, the quadratic must be 0. So, which means 1 minus x squared minus x equals to 0. Now, here we have to rearrange first before we use the formula, the quadratic formula, which means now I need to get positive x squared. So, since there is a negative x squared here, so I will move all the terms to the right hand side. So when you moved, it will be x squared plus x minus 1 equals to 0. And now you compare with the general quadratic equation, ax squared plus bx plus c equals to 0, before you apply the quadratic formula, because it's mentioned that your x in correct to 3 decimal places. That means now here it will be b squared minus 4ac over 2a. Alright, then I will be getting my a is 1 when you compare with the general quadratic equation. My b is also 1 because of 1x. My c is minus 1. Then the x is going to be minus 1 plus minus square root of b squared minus 4a is 1, c is minus 1. Then over 2a. Then from here, you will be getting minus 1 plus minus 1 squared is 1. So minus 4 times minus 1 is plus 4. So 1 plus 4, square root 5. Then over 2. Okay, then from here, when you calculate using the minus first. Minus 1 minus square root 5, you will get negative 1.62. Let me check. 3 decimal places. Okay, negative 1.62. Then it will be another decimal place. Let me calculate now. Sorry, 618. Okay, it should be 618. 3 decimal places. And the other one, when you use the plus to calculate, it will be 0.618. Okay, so now look at the question. Of this stationary point means that you are you should just find 1x. Okay, now look at the x value here. The x is between minus 1 and 1. That is the limitation of the x. Alright, given. Which means now we cannot accept the negative 1.618 because it's outside the range. Therefore, your x is 0.618. So this is the solution of this question. Okay, question number 3. The polynomial x degree 4 plus 3x cubed plus ax plus b, where a and b are constants, is denoted by px. When px is divided by quadratic function, the remainder is 2x plus 3. Find the values of a and b. Okay, so since we have the remainder here, and this quadratic cannot be factorized, you can just check using calculator. So the easiest way to solve this question is using polynomial division. So x degree 4 plus 3x cubed plus ax plus b. Okay, divided by quadratic divisor. Now, perform the long division. So, to get the x degree 4 from x squared, I need to multiply with x squared. Okay, I should leave a space for x squared. And there is no x squared in your px, so you just write 0x squared, then plus ax plus b. So now, I repeat again, to get x degree 4 from x squared, I need to times with x squared. So, x squared times x squared will be x degree 4. Then x squared times plus x cubed. X squared times minus 2 minus 2x squared over. Okay, then the next operation is you minus. So first one will be 0. Second term, 3x cubed minus x cubed is 2x cubed. Then the third term, 0x squared minus 2x squared plus 2x squared. Bring down the plus ax. Now, to get 2x cubed from 1x squared, we need to multiply with plus 2. Plus 2x, plus 2x. So it should be 2x cubed plus 2x squared minus 4x. Then now again, you minus. So first two terms, when you minus, you get 0 because they are identical terms. And the last term, right, the ax minus 4x, it will be a plus 4x. And now bring down the plus b. So to get a plus 4x, now you look at here, the divisor with degree 2. And now your remainder is degree 1 for the x, which means we should stop the polynomial division. Okay, now your remainder is a plus 4 times x plus b. And now it's given that it is 2x plus 3. So now I will just equate them to get the a and b. So now remainder equals to a plus 4 times x plus b. This is same as 2x plus 3. Okay, so now when I compare the coefficient of x. So that means now I will get a plus 4 equals to 2. Therefore, my a is 2 minus 4, which is minus 2. And then my b equals to 3. Okay, let me check. Okay, now wait. I copied the question wrongly. Okay, this is minus 1. I wrote minus 2. So here I have to change. Sorry about that. So this is minus 1. Okay, so when minus 1, which means this is 1. So here it should be 1 minus 2 is minus x squared. Then plus a plus 4x, then plus b. So to get x squared minus x squared from x squared, I need to times with minus. Okay, here it's supposed to be 2x. No problem. So I need to times with minus 1. Right, mistake. So then when I multiply with minus 1, okay, then it will be minus x squared. Minus 1 times positive x is minus x. Then minus 1 times minus 1 is plus 1. Okay, then again you minus. So from here, I will be getting first term is 0. Then the second term, let me check whether it's, okay, 2x times minus 1 is minus 2x. Again, this is mistake, minus 2x. Alright, so first term will be 0. Second term, a plus 2 minus 1. That means a plus 3x. Then b minus 1. That is the constant. And now, when you look at here, okay, the degree of the divisor is 2. Here, this is 2, highest degree. But right now, I'm getting x degree 1. That means I can stop the polynomial division. So now, I will just equate to the given remainder. And the remainder is 2x plus 3. So now you compare the coefficients for x and also constant. So it means that a plus 3 equals to 2. That means now your a is 2 minus 3, which is minus 1. And then b minus 1 equals to 3. Therefore, my b equals to 3 plus 1, which is 4. Okay, so this should be the correct working. Okay, now for question number 4, first part, express square root 6 sine x plus cos x in r sine x plus alpha, where alpha is greater than 0. Sorry, where r is greater than 0 and alpha is in between 0 and 90 degrees. State the exact value of r and give alpha equal to 3 significant figures. Okay, basically, when you look at here, this is sine, here is sine. Okay, so when sorry. But it follows the trigger functions over here. That means, sorry, the square root 6 is the a and the b is cos. Okay, we have a formula, general form. Alright, so if here sine, this is sine. That means now your r is square root of a squared plus b squared. then the alpha will be inverse tangent of b over a. So it must follow. Here sine, this is sine. Okay, so now what to do is, I will say that my r, my r, excuse me, is square root of square root 6 plus 1 squared, because the coefficient for cos is 1. Okay, so here you will get square root of square root 6 is 6, then you plus 1, that is square root 7. And that is my exact value of r. So for the alpha, right, so alpha is inverse tangent b over a. So your b is 1 here, 1 over square root 6. That means this is going to be 22.208 degrees as per requested 3 decimal places. Therefore, square root 6 sine x plus cos x, it will be square root 7 sine x plus 22.208 degrees. So that's the first part of question number 4. Okay, now B or part 2, hence means use the previous part, solve the equation. So now just now you got square root 6 sine x plus cos x. Okay, so I copy first from first part, square root 6 sine x plus cos x equals to square root 7 sine this. So square root 7 sine 22.208 degrees. So when you compare, right? So now sine 2x, sine 2 theta is sine x. That means your x has been changed to 2 theta. This is your x. So therefore, I will say square root 6 sine 2 theta plus cos 2 theta equals to 2. So I will let x equals to 2 theta. Hence, my left hand side will be square root 7 sine, okay, this one is missing, x plus. It should be x plus 22.208 degrees. So now I will change the x to 2 theta. Right? So 2 theta plus 22.208 degrees equals to 2. Because I'm changing the left hand side of the question here using the previous parts. That's the meaning of hence. Okay, so now when I need to solve this, what to do is sine 2 theta plus 22.208 degrees, it will be 2 over square root 7. Then from here, the 2 over square root 7 is basically, okay, I do not need to calculate this value first. Later, I just count directly. Okay, now what to do here is, you see, sine is positive. And then now I'm solving 2 theta plus 22.208 degrees. And now you are given this interval, which is between 0 and 180 degrees, which means to be safe, all right, get the new interval for this new theta. Okay, which means now I will write given theta between 0 and 180 degrees. Therefore, 2 theta, you just times 2, it will be between 0 and 360 degrees, and then followed by adding 22.208 degrees to the whole inequality. So it will be 2 theta plus 22.208 degrees. So for the lower limit, 0 plus 22.208 degrees, it will be the value. Then 360 plus 22.208, it will be 382.208 degrees. Okay, so from here, I will say my 2 theta plus 22.208 degrees. When you solve this question, when you solve this, right, you move the sign to the other side. Becomes inverse sine 2 over square root 7. Right, so now when I draw the quadrant by referring to this interval, that means now it will be first and last quadrant. I mean, you can accept, right, the value from 22.208 until 382.208. Now, when your sign is positive, that means the angle will be in first two quadrants. Alright, so now the basic angle. Alright, basic angle. Okay, I rewrite this first. 2 theta plus 22.208 degrees. So the basic angle equals to inverse sine 2 over square root 7. This is going to be 49.107 degrees. So I will label over here. Okay, so now my first angle 49.107. My second angle is 180 because one whole line, one horizontal line is 180. 180 minus this. Okay, but then when you look at the lower limit, 22.208, right? So my first value is 49. Second value is here. So then I cannot accept, I mean, you cannot consider 360 plus this because when you 360 plus 49 is already exceeding 382. Okay, so forget about this. Alright, therefore, your angle 2 theta plus 22.208 degrees, it will be 49.107 degrees, and then 180 degrees minus 49.107 degrees. Alright, then you will be getting 49.107 degrees, and the other one is 130.893 degrees. And now, when you solve means that you need to find the theta value. I need to find 1 theta is how much. So, the 22.208 degrees will be moved to the other side. That means it becomes minus. So, when you minus, right, yeah, I'm getting 2 theta equals to 26.899 degrees. And the other one, when you minus from 22.208, it will be 108.685. And now divide by 2. So when you divide by 2, you will be getting 13.4495 and followed by 54.3425 degrees. And now, look at the question first. Thus solve. Just for your information, if your angle is in degrees, it will be 1 decimal place. Therefore, now I need to round up. It will be 13.4 degrees and 54.3 degrees. So that's the solution of this angle. Okay, now question number 5. The equation of a curve is given and the A is positive constant. Now show that there is only one point on the curve at which the tangent is parallel to x-axis. So the tangent is dy dx. The gradient of tangent is dy dx. Okay, for your information, if this is a graph, tangent is parallel to x-axis means that the dy dx equals to 0. Right, so you need to show that when dy dx equals to 0, there's only one point. And find the y coordinates of this point. Alright, so then, now, what to do is, you need to differentiate. So, when you look at here, basically there are two terms. See? Multiplication of two terms. So, whenever you need to differentiate multiplication of two terms, that is the products rule. Products rule is uv, differentiate uv, that will be uv prime plus vu prime. So now I will just direct differentiate. So the first one is u. Okay, I will treat the 2x squared as u, the v is y, and then for the second term, the u is x and the v is y squared. So when I differentiate using this products rule, I will get 2x squared. Okay, now when you differentiate y with respect to x, we have another formula. So differentiate y, let's say fy, with respect to x. That is, differentiate fy with respect to y first, then you times with dy dx. That means now, when I differentiate using this formula, okay, so my y, I differentiate with respect to y, that is 1. Then I times with dy over dx according to this chain rule. Okay, then plus, according to the products rule, I need to plus, keep the y, and differentiate the u. So when you differentiate 2x squared, that is 4x. Okay, then minus, when you differentiate xy squared, keep the x, differentiate y squared with respect to y, that is 2y, and then followed by dy over dx. And now plus, keep the y squared, and differentiate the x, that will be 1. This is the products rule. So we perform the products rule twice. Now a cubed, a is a constant, so when you differentiate constant, it will be 0. Okay, now we need to get dy dx equals to 0, which means now I need to get my dy dx term. So I will do expansion first. When you do expansion here, all this just do expansion. Alright, I will be getting 2x squared dy dx. And then the second term is going to be plus 4xy. And then there's a minus outside. Don't forget about that. So I will be getting minus 2xy dy dx. And then minus times y squared is minus y squared equals to 0. Now, from here, I will group the dy dx on left hand side, and the rest of the terms will be moved to the right side, which means I will be getting 2x squared dy over dx minus 2xy dy over dx. And for your information, this plus 4xy and minus y squared will be moved to the other side. So when you move, remember to change the sign from plus to minus or from minus to plus. So I will be getting y squared minus 4xy. Okay, then from here, basically, when you look at the left hand side, I notice that 2x is in common, right? So I will factorize the 2x right now. So 2x and dy dx also in common. Then followed by x minus y from the left hand side. Then right hand side, y squared minus 4xy. Then get the dy dx as a subject. So to get the dy dx as a subject means that these 2x and this brackets move down. It's like division. Okay, and at the same time for the right side, I can factorize the y. Okay, so probably I will just factorize the y. Then here is going to be y minus 4x because the y is in common. Then now I will get y bracket y minus 4x divided by 2x bracket x minus y. This is my dy dx. Now, go back to the question. You want to show that there's one point when the tangent is parallel to x-axis. That means now I will let when the tangent is parallel to x-axis, dy dx equals to 0. So now, when my dy dx equals to 0, that means 0 equals to y times y minus 4x over 2x bracket x minus y. Okay, so again, to solve this, I will move up the denominator. So once you move up, it is still 0. So I'll get 0 equals to y bracket y minus 4x. Okay, so the multiplication of two terms equals to 0 means one of them must be 0. Either y equals to 0 or y minus 4x equals to 0. That means your y equals to 0 or y equals to 4x. Now, let's look at the graph, or let's look at the question. Show that there's only one point. Okay, one point means we expect only one x or one y. So now to check which y satisfy the equation, we have to substitute back into the equation right now. Okay, so I will write 2x squared y minus xy squared equals to a cubed. Okay, from this equation, when y equals to 0, left hand side, I will write 2x squared times 0 minus x times 0 squared. So basically it is 0. So it is not equals to a cube, which means, right, that means the y cannot be 0. Okay, so now I will just accept y equals to 4x. Right, therefore, or hence, y equals to 4x. Right, now, since we only get one y, now you need to show only one point. Okay, so what about the x? How many x we get? So now I will substitute back into this equation. Let's say I let this be first equation. So from first, right, when y equals to 4x, I will be getting 2x squared times 4x minus x times 4x squared equals to a cubed. Then for the first term, when you multiply 8x cubed. Then second term, bring in the square to the whole term. So I will get 4 squared is 16. So minus 16, x times x squared, x is x cubed. Then from here, I will be getting minus 8x cubed is a cubed. So now my x cubed, it will be minus 1 over 8 a cubed. So when you take cube root both sides, that will be x equals to minus 1 over 2a. So from here, I get 1y with 1x. Therefore, you just write here, hence only one point when the tangent is parallel to the x-axis. Okay, so now then we need to calculate or find the y coordinate of this point. So now again, you refer to your y. Y is 4x. Alright, so then from here, since your y is 4x, and then the x is negative half a, which means my y is basically 4 times negative half a. That is going to be negative 2a. Okay, so at last, you can just write y coordinate of the point equals to negative 2a. Alright, so done for this question. Okay, now question number 6. The variables x and theta satisfy the differential equation. For theta between 0 and pi, is given that x equals to 1 when theta is 1 over 3 pi. Solve the differential equation and obtain an expression for x in terms of cos theta. So in terms of x in terms of cos theta means that the x is a subject. Right, now sine half theta dx over d theta equals to x plus 2 of the cos half theta. So now to solve the differential equation, we need to separate the variables. Now when you look at this dx d theta, so the dx is the numerator. That means all the x should be on the left side. Right, so it means that this x plus 2, I will move to left side, and then all other theta will be moved to the other side. So which means you will be getting 1 over x plus 2 because x plus 2 multiply with the cos. Then dx, after that, the cos half theta divided by sine half theta. Then d theta. And now you integrate both sides. So this is how we integrate, how we separate the variables. Okay, now for your information, to solve both integration, we need to use ln formula. We have a formula here. ln formula is used when the degree of the denominator is 1. Okay, the whole function with degree 1. This is also degree 1. So now I will substitute back into this formula, which means I will write down the denominator first. So when we differentiate x plus 2, it's basically 1. So now it's exactly same as the left side. No need to times a constant outside. Now, right hand side, when you integrate sine half theta, the sine change to cos remain the half theta. But then when you differentiate half theta, that is half. Okay? Then this right side is exactly same as the formula right now. But then when you compare with the previous question, we need 1 cos half theta instead of half. So now the half is extra. Now, you are allowed to times a constant outside to make it to f prime x for you to use this formula. Therefore, I can just times 2 because half times 2 is 1. Okay, and now from here, left side, I will be getting ln x plus 2. I put a modulus here to make sure that it is a positive value when I substitute the x later on. Okay, if you are confirmed that it is positive, you can just put a bracket. So for the right side, it is 2 ln of the denominator. Then plus c. Okay, now replace the x by 1 and pi and theta by pi over 3. So when x equals to 1, theta is pi over 3. I will get ln of 1 plus 2 because it's positive, so I change to bracket. Then 2 ln sine. Here I know that it's positive because the angle is in the first quadrant. So in the first quadrant it's positive for sine. So you can just put a bracket. So half pi over 3. Okay, then from here, this is ln 3. Right side is 2 ln sine pi over 6. This sine pi over 6 is basically half plus c. Okay, now to get the c, it will be ln 3 minus 2 ln half. Now to simplify this c, because you have 2 ln here, we have a formula. Ln a minus ln b equals to ln a over b, provided the coefficients for both ln are 1. Here is 1, here is 1. If it's not 1 like this, this is 2. So I can move up. Right? So then I have another formula. Ln a power b is b ln a. So I may simplify this first. Ln half. Ln half is basically ln 2 to the power negative 1. You can use this method. Then the power negative 1, move it down. Alright? So, or this 2, you move up. So the 2, this is 2, so you move up becomes a degree. So here will be ln 3 minus, minus ln 2, or probably at the minus I move down. It will be easier. I want positive, I move down, the minus. So it becomes plus. So it will be plus 2 ln 2. You can use any methods to solve this. And then the 2 ln 2 I move up. The 2 I move up. These 2, these 2 move up. Okay? Because you are here now. This is 2. Move up. Then here I will be getting ln 3 plus ln 2 squared. So ln 2 squared is basically 4. So now because of the summation, so now I need to use another formula. Ln a plus ln b. That is ln a times b. So now I will just multiply. So it will be 3 times 4. That is ln 12. So this is my simplest value of c. Now, but then when you refer back to the question, you need to get x in terms of cos theta, which means that x must be the subject, right? Meaning to say that now you substitute this c, ln 12, into the previous solution. So I get ln x over 2, x plus 2 equals to 2 ln sine. 2 ln sine half theta, then plus c. c is ln 12. Now, to get the x as a subject, again, these two, I need to move up first using this formula so that I can simplify the ln. That means this is ln sine half theta squared plus ln half. So ln A plus ln B, it will be ln A times B. So square of sine half theta is basically sine squared half theta. Okay, and now I get ln both sides. Just one ln on both sides. Basically, you can cancel off the ln. Therefore, I will be getting x plus 2 equals to 12 sine squared half theta. And at last, your x will be 12 sine squared half theta minus 2. Okay, now look at the answer. The answer is cos theta. But then I'm getting sine squared right now. So what to do is, okay, refer to the cos formula then, cos theta. Because now look at here, cos theta, and this is sine half theta. So I refer to cos double angle formula for the cos. So cos 2a, and I need sine squared. So therefore, 1 minus 2 sine squared a. And now here, I need to get sine squared as a subject. So this move to the left side and the cos move to the right side. So I will get 2 sine squared a is 1 minus cos 2a. Okay, so then I compare. My a is half theta. This 12 is basically 6 times 2. So it will be 6 times this whole expression. Okay, then I will get 1 minus cos. A is half theta, which means now my 2a, because I need 2a. So my 2a will be 1 theta. So I will just direct change to 1 theta, then minus 2. And now when you open the bracket, that is 6 minus 6 cos theta minus 2. At last, 6 minus 2 is 4. So 4 minus 6 cos theta. This is your x in terms of cos theta. Okay, done for this question. Now question number 7. A. Find a complex number z satisfying the equation where this means the conjugate of the complex number. Give your answer in the form x plus iy where x and y are real. So I will let the complex number be x plus iy. Okay, then the conjugate, it will be x minus iy. So now I will just copy the question and replace. So now it becomes x plus iy, or before this, I will just multiply first, okay? Because after I multiply, then only I change to x and y. So I times the conjugate to the whole equation. So I will get complex number times conjugate plus I complex number minus 2 of the conjugate equals to 0. Then now I will replace. For your information, okay, from here, complex number times conjugate is basically x plus iy times x minus iy. So we have a formula, a minus b times a plus b. That is a squared minus b squared. So now my a, when you compare, my a is x. My b is basically iy. Okay, so this is a squared minus b squared. That is x squared minus I squared y squared. Remember, I squared is minus 1. Therefore, it becomes x squared minus 1 y squared. And I will write x squared plus y squared. So I will direct change the first term to be x squared plus y squared. Okay, then plus I of x plus iy, then minus 2 of x minus iy equals to 0. Now, when I do expansion, x squared plus y squared, then the I you move up, you move in. Okay, the 2 you also move in, the minus 2 you move in. So then you will be getting plus ix plus I squared y minus 2x plus 2iy equals to 0. Now for your information, I squared is minus 1. Okay, so here I will change this to minus 1. And then I rewrite now. It will be x squared plus y squared plus ix. Then this is minus y minus 2x plus 2iy equals to 0. Okay, so from here, I will group the real and imaginary parts. So for your information, real parts means those without I. So all these are real parts. I will be getting x squared plus y squared minus y minus 2x as my real part. And my imaginary part, it will be those with the I. Then once I have factorized the I, you will be getting x plus 2y and equals to 0. This 0 is basically 0 plus 0i. And now you can compare the real and imaginary parts, right? So I will get x squared plus y squared minus y minus 2x equals to 0. Let this be the first equation. And when I compare the imaginary part, x plus 2y equals to 0. Then from here, I can get the x or y as a subject. It's up to you. So my x is negative 2y. And let the x be the subject. So now, substitute second equation into first equation, which means my x will be replaced by minus 2y, then you square it, plus y squared minus y minus 2 of the x is negative 2y, then equals to 0. And now, just expand the first term. Square of minus 2 is 4. Square of y is y squared, then plus y squared minus y. And now, look at here. This minus 2 times minus 2y is plus 4y. So I get plus 4y equals to 0. Then, now simplify it. It will be 5y squared plus 3y equals to 0. And the y is in common. Then we can just factorize the y from both terms. You will get 5y plus 3 equals to 0. Now, look at the question over here. Your x and y are real. Okay, so it means that when the multiplication of two terms equals to 0 means either first term equals to 0 or second term equals to 0. So from the second term, I will be getting minus 3 over 5. So here I'm getting two y values. So when two y values, right, I need to check. So now, okay, so once you have found the y, you can just substitute into first or second equation to get the x. So obviously the second equation is easier because x is just minus 2y. So now I substitute into second equation. So when y equals to 0, right, x equals to negative 2 times 0. That is 0. Okay, so when 0 means that your complex number is 0. So when complex number is 0, you cannot divide by the conjugate, right? That means here, this one not accepted. Okay, so when y equals to negative 3 over 5, that means your x is negative 2y. So negative 2 times negative 3 over 5. This is going to be 6 over 5. So at last, my complex number is x plus iy. Refer back to my definition. This is my definition of the complex number. So replace the values accordingly. It will be x is 6 over 5 plus minus 3 over 5 because your y is negative. Therefore, end up with negative 3 over 5i. So that is the solution of this question. Okay, now for question B, first part. On a single Argand diagram, sketch the loci given by the equations modulus z minus 2i equals to 2 and imaginary part of the complex number is 3, where im is imaginary part. Okay, now first of all, change this to a general form. The general form is basically z minus a plus bi equals to r, and this representing a circle. with center AB, radius R. Okay, so from here, to get the radius and center, I will change it to general form. That means z minus 0 plus 2i. That is 2. So my center is at 0, 2. And then my radius is 2 units. So now, Im z is 3. This is Im of x plus yi equals to 3. The Im means imaginary part. Therefore, the imaginary part is basically referring to the y. So now I need to sketch both on the same diagram. Okay, so now, say this is the real axis. And here is the imaginary axis. Okay, my center is at 0, 2. Let's say here is 2. So now 0, 2, this is my center. Radius is 2 means 2 units up, 2 units left and right, and also down. Okay, so my circle will pass through all these points. Okay, my circle is not smooth. Probably I draw the circle first, then only I label. That will be easier for me, right? For you, you can just use coin to get a circle. That means here is 4. Okay, this is 2. Then here is minus 2. Right, so your circle is equals to 2. Right, there is a equal sign. There's an equal sign here, means that it will be on the circumference of the circle. And then another locus is y equals to 3. So y equals to 3, let's say here. So now this is imaginary of the complex number equals to 3. This one is modulus of z minus 2i equals to 2. So done for this part. Okay, now part 2. In the first quadrant, the two loci intersect at P. Find the exact argument of the complex number represented by P. Okay, first loci here, which is here now. This is your P. And then you need to calculate the exact argument. Okay, argument. So it refers to the origin, and this is the argument, theta. Okay, so how do we get this? Basically, right, I need to find out what is my length here. Okay, I know that this is 2. Okay, then now what to do is I need to find out what is my height here. This is 3. And I need to find out what is my horizontal distance. Okay, how do I get the horizontal distance? We know that the circle with radius 2. Alright, that means here is 2. Okay, then I need to know what is this length. So it is same as the horizontal distance over here. Then I know that this is 1. Okay, and here is 90 degrees. So by using this triangle, so I will just write here this is P. Here is at 2, here is at 3. So the distance here is 1. And then the radius is 2. So it means that here is 2. Alright, so let's say this is x. So now, this is using Pythagoras theorem. Your x is basically square root of 2 square minus 1 square. This is square root 3. So I know that this length, okay, here, square root 3. Which means this is also square root 3. Alright, so now I draw another triangle. This is a P, here is a O. This is the theta, and let theta be the argument of P, right, of OP. Okay, of P, right, should be of OP. Okay, so now I know that here is 3, and then the horizontal distance is square root 3. So from here, theta is argument, is arctangent, right? Because tangent theta is 3 over square root 3. So argument is arctangent 3 over square root 3. Then this is going to be arctangent of square root 3. And now, because of exact argument, that is pi over 3. So that is the solution for part 2. Okay, now for question 8, this is the fx. Express fx in partial fractions. Okay, first of all, you need to check, is the polynomial division needed? So look at here, the highest degree is 2 in the numerator, right? Highest degree is 2, but then when you do expansion for the denominator, it is cube, right? X degree 3. So it means that the polynomial division is not needed over here. So I will just write 2x squared plus x plus 8 over 2x minus 1 times x squared plus 2. Then this is, the first term is linear factor. So a over 2x minus 1. Then the second term, it is a quadratic, but it cannot be factorized. Therefore, linear function in the numerator. Now, to get the same denominator, you can always compare with the left-hand side. So I have 2x minus 1, means that I need to times with the quadratic. So x squared plus 2, x squared plus 2. Then same goes to the second term. You are given the quadratic right now, so just multiply with the linear function 2x minus 1. Okay, then from here, since you are getting the same denominator right now, so just cancel all the denominators and write down the numerators. So I will get 2x squared plus x plus 8 equals to a times x squared plus 2 plus bx plus c multiply with 2x minus 1. So let this factor be 0. I'm using the substitution method. So my x will be half. Okay, so you need to replace the x by half in this whole equation. That means now I'm getting 2 times half squared plus half plus 8. Then right hand side you will get a bracket half square plus 2. So the next term will be 0 because 2x minus 1 is already 0. Then from here, left hand side is 9. Okay, right hand side here, 1 over 4 plus 2, it will be 9 over 4. A. That means your A is 4. Now, we don't have other linear factor because this is quadratic. It cannot be 0. So you can just replace the x by value, by any value, but I will start with 0. So let x equals to 0. This is one of the methods. Otherwise, you can just do expansion. Okay, do expansion here. So expand everything, then compare with the left-hand side. There is another option. So when x equals to 0, left hand side 0, 0 plus 8. So I will write 8 equals to a times 0 squared plus 2 is 2 plus 0 times b, it will be nothing, then just left plus c. So 2 times 0 is 0, then left minus 1. Then from here to get the c, I will move this minus c to the left side and 8 to the right side. Therefore, I will be getting c equals to 2a. 2 times 4, because my a is 4. Then minus 8, which is 0. Okay, now I will let my x be any other number, let's say 1. So for left hand side, 2 times 1 square plus 1 plus 8 equals to 2a bracket 1 square plus 2 plus b times 1 is b, then plus c bracket 2 times 1 minus 1. Then left hand side here you will get 11. Now a is replaced by 4. 1 plus 2 is 3. Now remember your c is 0. So basically I'm getting just b bracket because here is 0. 2 times 1 minus 1 is 1. Then now my b equals to this 4 times 3, move to the other side. You will get 11 minus 12. That is minus 1. So I found my a, b, and c. So now just rewrite. Okay, substitute back into your partial fractions. So your fx equals to, your a is 4. So 4 over 2x minus 1. Now plus bx plus c. Okay, over x squared plus 2. But then we don't leave our answer in this form, the second term, so simplify it. So it will be 4 over 2x minus 1. Now basically the second term here, the numerator, just ignore this, and there is a minus. So minus times plus is a minus. I will just write minus x over x squared plus 2. So that is my partial fractions. Okay, part 2. Hence means use a previous answer. Show full working this integration and leave your answer in the form of ln c, where c is an integer. Okay, so now integrate 1 to 5 fx dx. That is integrate 1 to 5. Just copy the partial fractions. 4 over 2x minus 1. Then minus x over x squared plus 2. Okay, so now here I will split into two integrations, and I notice that the degree 1 for both denominators. Therefore, I'm using ln formula again. Alright, so I will rewrite over 2x minus 1 dx. So when I differentiate 2x minus 1, it is 2. But the question is 4 in the numerator. Therefore, times another 2 outside. And minus integrate x squared plus 2 dx. When I differentiate x squared plus 2, it should be 2x. But here only 1x, means I need to times half outside to make it to 1x. Therefore, with this, I'm getting 2 ln 2x minus 1. Okay, my x are positive values, so I'm confirmed that and some of they are integers, so I'm confirmed that it will not be negative for the values inside the ln. So that's why I put bracket. You can use modulus, it's up to you. Okay, then minus half this whole integration from 1 to 5, it will be ln x squared plus 2, and again it will not be negative because of the x squared. Okay, x squared plus 2. So here from 1 to 5. So now just replace the x by 5 first. 2 ln 2 times 5 minus 1 is 9, minus half ln 5 square is 25. 25 plus 2, 27. Okay, then minus, when the x is replaced by 1, so I get 2 ln 2 times 1 minus 1 is 1, minus half ln 1 square plus 2 is 3. Then from here, right, because the question says ln c. C is integer. Okay, so from here, I will simplify the 2 ln 9 first. So a ln b is ln b to the power of a, because later on when we need to combine with other ln, right, we need to make sure the coefficient for ln must be positive 1. The coefficient for the ln must be 1. So that's why I move up the 2. So ln 9 squared. This half I move up, minus ln 27 to the power of half. Okay, then ln 1 is 0, no need to count. This minus times in, it becomes plus half ln 3. So plus the half I move up, so ln 3 to the power of half. Okay, so here I rewrite. This is basically ln 81 minus ln square root 27 plus ln square root 3. Now, we have another formula. Ln A plus ln B is ln AB. Where else? Ln A minus ln B, it becomes ln of A divided by B. Okay, so now I will combine these two formulas together. So this is ln 81 over square root 27 because of minus. But then followed by plus. Plus means times square root 3. Okay, then from here, I will get ln 81. Now, for your information, this square root 27 is same as square root 3 times square root 9. Then times another square root 3 on top. Because of this formula, square root AB equals to square root A times square root B. So now the square root 3 will be cancelled off. And then we know that square root 9 is 3. So this is ln 81 over 3. And you will be getting ln 27. So that is the final answer. Okay, now next question number 9 is given this integration is 3, where a is between 0 and 3 over 2 pi. Show that a satisfies this equation. Okay, so now means that we need to integrate first, otherwise you won't get the a. So integrate from 0 to a, x cos 1 over 3x dx equals to 3. Okay, to solve this integration, you have two terms here, right? Multiplication of two terms. Therefore, we need to apply the integration by parts. Integrate u v prime dx equals to uv minus integrate v u prime dx. Right, so now my u is the x. So I will write down here, u is x. My u prime is 1. V prime is cos 1 over 3x. So my v is integrate cos, you get positive sign. Rewrite 1 over 3x and divide by differentiation of 1 over 3x. It is 1 over 3. So from here, 1 divided by 1 over 3 is basically 3. So I will simplify it into this form. Okay, now use this formula, integration by parts. So I will get uv, so x times this, it will be x times sine. X times 3 sine 1 over 3x. This is my uv, minus integrate from 0 to a, now with limits. Okay, vu prime. So 3 sine 1 over 3x. All this multiplied with 1 dx equals to 3. Okay, so you replace the x by a first. So that means I'm getting 3a sine 1 over 3a minus, when the x is replaced by 0, so you get 0. Then now minus integrate 3 sine 1 over 3x. So when you integrate sine, that is minus cos. So here I will write 3a sine 1 over 3a minus, okay, take out the 3. So when you integrate the sine itself, integrate sine, it will be minus cos. So I will write minus cos 1 over 3x divided by 1 over 3. From 0 to a, that equals to 3. Then from here again, replace the x by a. And at the same time, okay, this 1 over 3, I move up. That means you are getting 3a sine 1 over 3a minus minus is a plus. So 3 times 3, then cos replace, right? So it will be cos 1 over 3a minus cos 0. So for your information, cos 0 is 1. Okay, this is 9. So you just need to times into the bracket. So I will get 3a sine 1 over 3a plus 9 cos 1 over 3a. Then 9 times minus 1 is 9 and equals to 3. Now let's look at the question. You need to prove this. You have the sine a sine 3a together, okay? A sine 3a together. So it means that now I need to get a sine 3a as a subject. So which means I need to move all these terms to the other side. Alright, that means here you will be getting 3a sine 3a, 3a sine 1 over 3a equals to 3 plus 9 minus 9 cos 1 over 3a. Now, to get the a, okay, look at here. To get the a, right, I should get a sine half 1 over 3a first. So it means that now I need to get a. So what to do is I will move down 3 and the sign. Okay, so that means I will get a equals to 9 plus 3 is 12. Then copy the rest and then over 3 sine 1 over 3a. And then now look at the answer. 1 sine 1 over 3a. That means now you take out the 3 from the numerator. So that means 4 minus 3 cos. So now the 3 will be cancelled off. Okay, therefore, this is 4 minus 3 cos 1 over 3a over sine 1 over 3a. So that's all for the solution. Right? Now verify by calculation that a lies between 2.5 and 3. So for this, I will just move this term to the other side and let it be fa. So now a minus 4 minus 3 cos 1 over 3a over sine equals to 0. So I let fa be the left hand side. Okay, to prove that it lies between 2.5 and 3, so just replace the a by the two values. And now when you do calculation, remember this is in radians mode. Okay, so change the mode of the calculator to radians first before you calculate. And this is going to be negative 0.179, which is less than 0. And now we calculate f3. So replace the a by 3. So 3 minus, just rewrite all these terms. this is going to be 0.173, which is greater than 0. So according to the sign change rule, okay, so since f 2.5 less than 0 and f3 is greater than 0, there is a sign change. Hence, A lies between 2.5 and 3. Okay, that is the sign change rule. Now, part 3. Use an iteration formula based on the equation in part 1 to calculate alpha equal to 3 decimal places. Give the result of each iteration to 5 decimal places. Now, use back this formula. Right, this formula. So, but then to get the iteration formula, you need to add on the subscripts. Okay, so I will get an plus 1 equals to 4 minus 3 cos 1 over 3 an over sine 1 over 3 an. So since your previous part, we have proven that a lies between 2.5 and 3. That means you can choose your a naught, which is the initial a, as 2.5, 3, or any other numbers in between this interval. So I will let my a naught be the value in between, which is 2.75, the middle value. Then now you just replace accordingly. So a1 will be 4 minus 3 cos 1 over 3 times 2.75, then divided by sine 1 over 3 of 2.75. And now 5 decimal places. So that will be 2.74024. Okay, so when do we stop? You need 3 decimal places for final answer. So you should get same 3 decimal places. Obviously they are not the same. Then we need to continue. So A2 is 4 minus 3 cos 1 over 3 times 2.74024 over sine 1 over 3 of this value. So just continue. Right, this is going to be 2.73733, and again they are not the same because previously 2.740, now 737. So I need to continue again. So now I will just rewrite all this. This is 2.73648. Right, so now continue. A4. Then this is going to be 2.73643. Okay, so now you are getting the identical 3 decimal places. Therefore, refer to the last value and refer to A4 and decide whether you want to round up or not. So since it is 2, that means I will just ignore the 2. Okay, so my A is approximate to 2.736. So that is the solution of A. Okay, so for question number 10, the line L has equation R equals to I plus 3j minus 2k and lambda I minus 2j plus 3k. The plane has equation 2x plus y minus 3z equals to 5. First part, find the position vector of the points of intersection of L and P. Okay, just for information, this is 2019 paper, but starting 2020, okay, the plane related question has been moved to further mathematics. Alright, so if you need to learn this, I'm showing it now. okay, just for your extra information, just for your extra knowledge. So from here, from the R, I will change to this form, which is 1i 3j minus 2k plus lambda of 1i minus 2j positive 3k. Okay, then from here, I will change the R into x, y, z. So here, x, y, z equals to, now open the bracket, it will be 1 plus lambda, then 3 minus 2 lambda, minus 2 plus 3 lambda. Okay, in other words, I will say that my x is 1 plus lambda, my y is 3 minus 2 lambda, and then my z is minus 2 plus 3 lambda. So now, you need to find the intersection between the line and plane, means that now you are solving simultaneous equation. So just solve all this into the plane equation. So now, plane equation is 2x plus y minus 3z is 5. So I substitute first into second. So it will be 2 of 1 plus lambda plus 3 minus 2 lambda minus 3 of minus 2 plus 3 lambda equals to 5. Now just do expansion. 2 plus 2 lambda plus 3 minus 2 lambda, and then followed by this minus 3 bring into the bracket, and then you will be getting plus 6 minus 9 lambda equals to 5. Okay, so simplify first. 2 lambda minus 2 lambda is 0. Then I get minus 9 lambda, and then the rest of the terms just move to the other side. This is 5. 5 plus 6, 11. Move it to the left side. So 5 minus 11 is minus 6. Therefore, my lambda is minus 6 over minus 9, which is 2 over 3. Now, you need to find position vector of the intersection point. Since you have found the lambda, so now substitute lambda into your R. So I will get my R equals to 1. Okay, substitute into here. So 1, 3, negative 2 plus lambda. So plus 2 over 3 minus 2 lambda. So minus 2 of 2 over 3. And then the other one is plus 3 lambda. So plus 3 of 2 over 3. Then this is going to be 5 over 3. And then 5 over 3. And then here is 0. So now the intersection point, okay, the question asking for position vector. So position vector equals to 5 over 3i plus 5 over 3j. Okay, so that's the solution of this question. Now, part 2, find the acute angle between L and P. Okay, just for information, let's say this is L. Right, and this is the pi or P. So basically the angle between L and P is here. This is alpha. But then for the plane, we will have the n. Because a plane is basically R dot n equals to A dot n. Okay, then this line we have B. So the angle that you find from B and N is theta, and now we need to find alpha. Okay, so let alpha be the angle between L and P. Theta is the angle between B and N. The N is the normal vector from the plane. So now, to get the angle theta, I will use the the scalar product formula. So your B is basically this. This is your B. Okay, so it will be 1, negative 2, 3. Now the N, just for information, the N is basically from here. Okay, 2x plus y minus 3z. So 2x plus y minus 3z equals to 5. This is same as r dot, okay, or I would say it is x, y, z dot 2, 1 minus 3 equals to 5. Therefore, this is your r dot 2, 1 minus 3 equals to 5. This is your n. Right, so here 2, 1 minus 3 equals to modulus of minus 1 squared plus 2 squared plus 3 squared, then another modulus 2 squared plus 1 squared plus minus 3 squared, and then cos theta. Then for the left hand side, you just multiply, okay, because this is a dot product. Multiply and then you plus. So I will get minus 1 times 2 plus 2 times 1 plus 3 times minus 3. Then for the first square root, that is square root of 14. Second square root, also square root of 14. Then cos theta. Then for the left hand side, you will be getting, now first two terms will be cancelled off because minus 2 plus 2. Then here you get minus 9. So minus 9 equals to 14 cos theta. Therefore, my cos theta is minus 9 over 14. Hence, my theta is inverse cos negative 9 over 14. That is 130.0 degrees. Right? So, I found my theta value. So, which means my diagram shouldn't be like this, because if I refer to this diagram, the theta is between 0 and 90 degrees. So now my diagram supposedly like this. So this is my L, here is my P. Okay, so my angle is, this is my N, and here is my B. So I'm finding this angle. This is my theta. And then now my alpha is going to be over here. My alpha is between line and plane. Line and plane, that means right here is 90 degrees. So my alpha is this part. Line and plane. Line and plane. Wait, let me check. It will be line and plane, B and N. B and N. B and N is here. Theta. So line and plane. Line and plane, it will be, okay, line and plane is over here. So line and plane, alpha. Okay, and not this. So obviously from here, your alpha equals to theta minus pi minus 90 degrees. Therefore, it will be 130.0 minus 90, which is 40.0 degrees. Okay, done for this part. Now a second plane Q is perpendicular to the plane P and contains the line L. Find the equation of Q, giving your answer in the form AX plus BX plus CZ equals to D. Okay, so for this case, let's say now you are given this is the P. Perpendicular to P means this is your Q. Okay, and this Q you have L. Let's say this is the L. Because we have proven from the previous question, right? The L is in this direction. So now, from the Q, we need to find NQ. Okay, I need to find NQ. And then for the P, I have NP. So obviously, NP is perpendicular to NQ, right? Because they are perpendicular to each other here. And then for the L, I have B. Okay, so from here, I will say that my NP, okay, let NQ equals to ABC, because it's mentioned in ABC. So NP dot NQ equals to 0. Therefore, my NP just now 2, 1 minus 3. You can use this method or you can just use a cross product. So I show you the scalar products over here. Then from here, you just multiply to get first equation. Okay, because we need to find the NQ and also we have to find the point. The point is basically, you can just take the L. The purpose is I need to find the NQ. So now, since we have 3 equations here, I need to find another equation, 3 unknowns, A, B, C, I need to find another equation. So from here, you should understand that because your P, right, the Q contains L. That means the L is on the Q, right? That means B is perpendicular to NQ as well. So it means NQ dot P equals to 0. So now, use the same method. The B is 1, negative 2, 3. Therefore, I get A minus 2B plus 3C equals to 0. That is my second equation. Now, to solve these 2 equations, now I only have 2 equations, but with 3 unknowns. That means you will get infinite solution. Now, I notice that I have different multiple of A in both equations, different multiple of B in both equations, but same multiple of C in both equations. But one is minus 3C, another one is plus 3C, which means now to eliminate the C, I have to add these 2 equations. So first plus second. So 2A, look at here, 2A plus 1A, I get 3A. So 3A, and then followed by the B, plus B plus minus 2B, that is minus B. So the C is cancelled off. Then from here, my B equals to 3A, right? So I can let my A be any numbers, let it be T, because I will be getting infinite solution. So therefore B is 3T, and now I substitute this 3T into first and second equation, right, to get the C. So you can substitute into first or second equation. So now from first equation, I'll get 2A, so 2T, plus B is 3T, then minus 3C equals to 0. So now my 3C minus 3C will be moved to the other side. Therefore, you are getting 3C equals to 5T, hence my C is 5 over 3T. And now I need to find NQ. My NQ consists of ABC. So I will rewrite now. So my NQ, or probably I don't write NQ first, I will write ABC first. ABC equals to, my A is T, my B is 3T, and then my C is 5 over 3T. From here, I can factorize 1 over 3T, because I do not prefer the fraction in the end. Right, so when I factorize 1 over 3T, the first one left 3, the second one is basically 9, and the last one is 5. Then from here, I will say that my NQ is 395, because that is perpendicular, that is parallel to this vector. Alright, now at last, equation of the plane Q, that is x, y, z. Okay, or I will start with the formula first. That is r dot n equals to a dot n. So my r you change to x, y, z because you are getting the Cartesian equation. So 395. Then the a is the point on the plane. So since your plane has line L, then I can just take the point on the line L. That is 1, 3 minus 2. So here becomes 1, 3 minus 2 dots with 395. Okay, then from here you will be getting dots product. Right hand side also dots product. So 1 times 3 plus 3 times 9 plus negative 2 times 5. So at last you are getting the plane equation as follows. So this is going to be 20. So this is the long method, right? That means we are using dots products to find the NQ. So now I show you the alternative method shortcut. So to get the NQ, right? So you can just times the plane vector, the n from the plane P and the straight line, because we know that this is the plane Q and it is perpendicular, alright? So from here, this is a line L. Line L has B, and then this is the plane P. So it itself has the NQ. So from here, the NQ is perpendicular to B, right? And also perpendicular to NP. So according to the vector product, so then the cross product of the NP and B, it will be perpendicular to the, I would say that NP cross B is perpendicular to both NP and B, right? Therefore, the shortcut is you just use the cross product. So your NP is basically 2, 1, negative 3. Then you cross with 1, negative 2, 3. So to evaluate this cross product, right? So you just use this method. The first one is plus. And then now you cover. So cover this and then you use cross multiplication. So then you will be getting 1 times 3 minus negative 3 times negative 2. Followed by negative. Now you cover the second row. So when you cover second row, right, then you cross multiply. So that is 2 times 3 minus 1 times minus 3. Same goes to the last row. So when last row, you cover the last row. Okay, then cross multiply. So that is going to be 2 times minus 2 minus 1 times 1. Then here, you will be getting minus 3, minus 9, minus 5. Then I will say that my NQ is parallel to NP times Q, which means my NQ is basically 395, because you can factorize the minus. So this NQ, right, is exactly same as the NQ over here. So that is the shortcut. But we are using cross product. And again, the cross product is in the further maths right now. Alright, so that's all for this solution. Alright, so we have completed the whole paper and it also comes to the end of the video. Thanks for watching. If you enjoy watching my video, please like this video and subscribe to the channel. And don't forget to share it with your friends. Alright, and if you would like to support this channel, please click the thanks button just below the video. Okay, so stay tuned for more upcoming videos. Thank you. Bye.